8th grade, Unit 3, Lesson 7, Representations of Linear Relationships. Problem number 1, from 8th grade, Unit 3, Lesson 4. Here are recipes for 2 different banana cakes. Information for the first recipe is shown in the table. The relationship between cups of flour, Y, and cups of sugar, X, in the second recipe is Y equals 7/4 times X. This table represents the first recipe, and this equation represents the second recipe. A. If you used 4 cups of sugar, how much flour does each recipe need? The left-hand column of this table represents X, and the right-hand column of this table represents Y. To get 4 cups of sugar, I'd have to multiply 1/2 a cup of sugar times 8. And if I multiply the X column by 8, I need to multiply the Y column by 8. So 1/2 times 8 is 4, and 3/4 times 8 is 6. In the first recipe, for every 4 cups of sugar, there are 6 cups of flour. In the second recipe, Y represents the number of cups of flour. So the number of cups of flour will equal 7/4 times X, or 7/4 times 4, if there's 4 cups of sugar. And 7/4 times 4 is the same as 7/4 times 4 over 1, which is 28/4, or 28 divided by 4. And 28 divided by 4 is 7. So in the second recipe, for every 4 cups of sugar, there are 7 cups of flour. In the first recipe, for 4 cups of sugar, you would have 6 cups of flour, and in the second recipe, for 4 cups of sugar, you'd have 7 cups of flour. B. What is the constant of proportionality for each situation, and what does it mean? For the first recipe, we can divide 3/4 by 1/2, which is 1.5. So the constant of proportionality for the first recipe is 1.5. 1 cup of sugar to 1.5 cups of flour. For the second recipe, we can divide 7 by 4. 7 divided by 4 equals 1 3/4. So for the second recipe, the constant of proportionality is 1 3/4, which means for every 1 cup of sugar, there's 1 3/4 cups of flour. Problem number 2, from 8th grade, Unit 2, Lesson 6. Show that the 2 figures are similar by identifying a sequence of transitions, rotations, reflections, and dilations that takes the larger figure to the smaller one. Let me show you a quick animation, and then I'll tell you what I did. First, translate point H to point D. Second, reflect across a vertical line at point D. And last, dilate using a half-scale factor using point D as center. Problem number 3. Create a graph that shows 3 linear relationships with different y-intercepts using the following slopes, and write an equation for each line. The first slope is 1/5. Let's start writing the equation with y equals 1/5 times x, and then let's make the y-intercept 1. So now the equation would read y equals 1/5 times x plus 1. We could put some points on this line. Let's go up 1 and over 5. There's another point. Let's go up 1 and over 5 again. There's another point. And here's a look at the line that has a slope of 1/5. The second slope is 3/5. So let's start out with y equals 3/5 times x. And let's make the y-intercept 3. So now the equation reads y equals 3/5 times x plus 3. Let's put another point by going up 3 and over 5. There's another point. Let's go up 3 and over 5 for a third point. And here's a look at a line that has a slope of 3 over 5. And the last slope is 6 over 5. Let's start the equation with y equals 6 over 5 times x. Let's make this y-intercept 2. So now the equation would read y equals 6 over 5 times x plus 2. Let's add some points to this graph by going up 6 and over 5. There's a location of another point. Let's go up 6 and over 5. And there's our third point. Now here's a look at a line that has a slope of 6 over 5. Problem number 4. The graph shows the height in inches, h, of a bamboo plant t months after it has been planted. A. Write an equation that describes the relationship between h and t. The vertical axis h is like the y-axis, and the horizontal axis t is like the x-axis. When we write the equation y equals the slope times x plus the y-intercept, we can substitute the y and the x with the h and the t. Now it reads h equals slope times t plus y-intercept. And the y-intercept is 12. So the equation would read h equals slope times t plus 12. Since the rise is 15, counting by 5s, and the run is 5, counting by 1s, the slope is 15 over 5, which is the same thing as 15 divided by 5, or 3. Now I just noticed a misprint down at the bottom of this graph in t months. It says 5, 5 when it should say 5, 6, so I'll fix that. I'll substitute the slope for 15 over 5, or 3, and now the equation reads h equals 3 times t plus 12. The equation that represents the relationship between h and t is h equals 3t plus 12. B. After how many months will the bamboo plant be 66 inches tall? Explain or show your reasoning. I'm going to substitute the h, or height in inches, with 66. Now the equation reads 66 equals 3 times t plus 12, or 66 equals 3t plus 12. To solve for t, we have to take away 12 from both sides. 12 minus 12 is 0, and 66 minus 12 is 54. So now the equation reads 54 equals 3 times t. To make the t just 1 t, we have to divide by 3. Since we've divided the time by 3, we need to divide the inches by 3. So 3 divided by 3 is 1, and 54 divided by 3 is 18. Help me help you by disrupting YouTube's algorithm. Like, comment, share, and subscribe.